Hello friends, welcome to all in my YouTube channel all about civil engineering by PRAVIN and PM Educational Academy. Here I am PRAVIN having experience of more than 14 years in industrial experience as well as teaching experience. So today I am going to explain about the MCQs which are useful for competitive examinations like GATE, MPSC, UPSC, any competitive examination in civil engineering. So, the subject today I have chosen for MCQ preparation is bridge engineering. So, bridge engineering is very important and very vast subject from civil engineering. So, today we will start without wasting time. We will start the session. So, question 1, an ideal bridge site should have stream is well defined and narrow, it has square alignment and it has firm and permanent river bank. So, this will be the ideal bridge site. Then for a bridge, L is equal to clear span, N is equal to number of spans and B is equal to width of pier, then length of bridge is equal to L is equal to N into L plus N minus 1 into B. So, number of piers is equal to N minus 1. So, third, linear waterway for river at bridge site is equal to sum of all clear spans. Then Lassie's regime formula for linear waterway of alluvial soil is L is equal to C into square root of Q, C into square root of Q, where C is equal to constant for alluvial soil, C is equal to 4.5 to 6.3 and Q is equal to design flood discharge which is available in meter cube per second, and C is constant, so it has no unit. Increase in water level at the bridge site due to obstruction to the flow is called as afflux. Increase in water level at the bridge site due to obstruction to the flow is called as afflux. Minimum freeboard required for high level bridge is 600 mm. A minimum freeboard required for high level bridge is 600 mm. Then if Q is the discharge in meter cube per second, the regime width of stream is given by regime width is equal to 4.8 into square root of Q. So, 4.8 C into square root of Q. Q is the discharge. The normal score depth is given by for any bridge is given by D is equal to 0.473 into bracket Q divided by F raised to 1/3. Then if P is equal to cost of one pier with its foundation and A1 small a1 is equal to constant for superstructure, then the economic span of the bridge is given by formula L is equal to square root of P divided by A1. P is the cost of one pier with its foundation and A1 is the constant for superstructure. Then economic span is equal to economic span of bridge is given by L is equal to square root of P divided by A1. In suspension bridge, deep is usually taken as 1/10 of span. In a suspension bridge, deep is usually taken as 1/10 of span. In case of balanced cantilever bridge, the cantilever span is usually taken as 20 to 25% of the supported span. In case of balanced cantilever bridge, the cantilever span is usually taken as 20 to 20% of the supported span. Then viaduct is a long continuous structure supported on trestle bends or a dry valley. Viaduct is a long continuous structure supported on trestle bends or a dry valley. The bearing which permit horizontal movement as well as rotation is called as rocker or roller bearing. The bearing which permit horizontal movement as well as rotation movement. So it will be rotating movement, it will permit rotating movement. That bearing is called as the rocker or roller bearing. The width of expansion joint in highway bridges is usually 25 mm. The width of expansion joint in highway bridges is usually 25 mm, that is 1 inch. The minimum width of carriageway for 2-lane bridge is 7.5 meter. The minimum width of carriageway for 2-lane bridge is 2-lane bridge and carriageway length 7.5 meter. Which of the following loading class for bridges is the highest loading? That is a class 70R. Which of the following loading classes for bridges is the highest loading? That is the class 70R. Means live loads for various loadings are. This is the explanation. Live loads for various loadings are class 70R is equal to tracked vehicle 700 kN and wheeled vehicle 1000 kN. Class AA, tracked vehicle 700 kN and wheeled vehicle 400 kN. So here in difference between class 70R and class AA, as far as loadings are concerned, for tracked vehicle the loading is equal, loading is same, but as far as wheeled vehicle is concerned, class 70R bridges, class 70R loadings is 1000 kN, as far as class AA vehicle loadings are, wheeled vehicle loadings are 400 kN. For IRC, Indian Road Congress, IRC loading 70R and AA, the impact factor is taken as 25% for up to 9 meter span. If span of bridge is 9 meter, for IRC 70R and AA, that is the loading class 70R and class AA, the impact factor is taken as 25%. The wind load acting on moving live load will be assumed to act at a height of 1.5 meter above the roadway. Its value for ordinary bridge is 3 kN per meter wind load. What we will assume for as far as ordinary bridge? We assume that the wind load acting on moving live load, so vehicles are moving, so they are having moving live load. So vehicles, those are moving, that creates moving live load on bridge, and the wind load of that moving live load, wind load acting on that moving live load, means wind load acting on vehicle which is in moving condition is assumed, we will assume that will act at a height of 1.5 meter above the roadway, and its value for ordinary bridge is 3 kN per meter. For ordinary bridge, what we will assume that the wind load acting on moving live load is 3 kN per meter. Now, bridge railings and parapets should be designed to resist a lateral horizontal force and vertical force each of 1.5 kN per meter acting simultaneously. So, whatever bridge railings or parapets will design for as far as bridges are concerned. So, what we will assume that this load acts simultaneously. One thing is this load acts simultaneously, and their magnitude of that load is 1.5 kN per meter 1.5 kN as far as horizontal force as well as vertical force acting on bridge railing and parapet. Now, Dickens formula to determine discharge is Q is equal to C into A raised to 3 by 4. Dickens formula to determine discharge is Q is equal to C into A raised to 3 by 4. Rives formula is Q is equal to C into A raised to 2 by 3, where Q is discharge meter cube per second unit is, and A is the area of catchment in square kilometer. See, area of catchment in square kilometer. So Deccan given formula to determine discharge is Q is equal to C into A raised to 3 by 4. Railway given formula Q is equal to C into A raised to 2 by 3. Railway 2 by 3 A raised to, and Deccan A raised to 3 by 4. C is the constant. Railway is constant and Deccan's constant. The length of the downstream portion of the guide bank should be 1/4 of bridge length. 1/4 of the bridge length. The top width of guide bank should not be less than 3 meter. The top width of guide bank should not be less than 3 meter, but it should be in proportion, that is 1/4 of bridge length. Which of the following is a river training work? Which of the following is the river training work? River training work. So river training work, guide banks, it is also river training work. Spurs, these are also river training work. Cutoffs, these are also river training work. So all the above is the river training work. So here, which of the following is the river training work? River training works are guide banks, spurs and cutoff. All these are river training works. River training, we are guiding river. We are guiding river or guiding to its path. Guiding path to river. We are guiding path to river. Then the upstream curved head of guide bank generally subtend an angle with the center line of bridge equal to 120 degree to 145 degree. The downstream curved head make angle 45 degree to 90 degree with the center line of bridge. On piers parallel to the direction of current, the intensity of water pressure is P is equal to 0.5 kV square, where P in kilonewton per meter square, V in meter per second, K is the constant. P is the water pressure, V is the parallel to the direction of current, the intensity of water pressure is P is equal to 0.5 kV square. K is the constant, V is the meter per second, its velocity of water. P is the pressure. The collision load on bridges piers, the collision load on bridge piers may be taken parallel to the carriageway equal to 1000 kilonewton. The collision load on bridge piers may be taken parallel to the carriageway equal to 1000 kilonewton. Collision load perpendicular to the carriageway is taken as 500 kilonewton. So collision load on bridge pier may be taken parallel to the carriageway. If load is parallel to the carriageway, it is 1000 kilonewton, and if this load is perpendicular to carriageway, it is 500 kilonewton. So thank you for watching the video. If you like it, please do share it and subscribe the channel for more such fruitful videos. Now afterwards, I am explaining such simple and useful and necessary MCQ questions through this channel. If you like it, please do share it and subscribe the channel, and also share these videos with your colleagues, your friends, those who need it. Thank you for watching the video. Again, please join us PM Educational Academy online. I am giving nowadays this, I am delivering such lectures nowadays online, in online mode. So this is freely available. You have much of time with you. You need to prepare for examinations, and the knowledge is very much important as far as civil engineers are concerned, or everybody concerned. We require such type of knowledge. So you just listen this carefully, watch this carefully, like this, subscribe the channel, so that you will get intimation of any video I am uploading. Thank you.